Well, hello there. So today I want to talk about agentic engineering. Now, this is a pretty new term that's been popping up all over social media lately, and I know a lot of people are gonna probably say, isn't this just vibe coding? And in my opinion, it's totally different. There's a big difference between people just prompting ChatGPT or Gemini and one-shotting some code that they're gonna copy paste and saying, hey, look, I built something. And when you look at the image, it's just pointing to their local host. There's a big difference between that and what I do at work every single day. And don't get me wrong, I think it's amazing that a lot of people are actively trying to build things and they're just excited about AI coding and just doing things. And I think that is great, but on the flip side, the term like vibe coding being synonymous with AI coding, in my opinion, is essentially a disservice to the entire industry. Basically, when everyone who is doing AI coding is getting lumped up all together with vibe coding, I don't think that's the right approach. So today, we're gonna talk about what agentic engineering is and what I think are the 5 pillars that make up this new practice. Before we dive in, I wanna give 2 really good examples of this new term, agentic engineering. And I think Andre Karpathy tweeted about this, saying that what he's doing these days is not so much as vibe coding, but agentic engineering. And he specifically called out the use of the word engineering in this because honestly, it is engineering. There's so much thought and a lot of designing, system designing, and just a ton of work that goes into this new workflow and this new practice. And another really good example is from Peter Steinberger, who recently joined OpenAI. But I saw pockets of him with Gergely on the Pragmatic Engineer, and he also described that his work is agentic engineering. He even goes as far as to saying vibe coding is basically a slur now.
I think vibe coding is by now almost a slur.
Oh yeah.
I call it. I tell people what I do is agentic engineering with a little star. Vibe coding starts at 3 a.m.
And honestly, that was so relatable to me because I've definitely been there in those late nights when I'm no longer following the best practices and these pillars that I'm gonna talk about. Now, another interesting thing about all of this like agentic engineering stuff is that I actually discovered a lot of these pillars on my own, just through working with AI models every single day. And it kind of started before Opus 4.5 came out, but when that model came out, something like really shifted in the way I started to work because the models just became so capable and the tools around the model just had this moment where everything just clicked. And that's why you see Cloud Code and Codex app and all these agentic coding apps are just blowing up right now. And it's so interesting to me that all of these people that are actively building with these things are all kind of diverging on these like common topics, common things that is turning out to be this thing called agentic engineering. Okay, that was a long-winded setup, but let's get right into what is agentic engineering. Pillar number 1 is context engineering. And if you've seen any of my previous Cloud Code videos, I think context engineering is king. Context is king. Context is best served fresh and condensed. Now, all of these pillars are very important, but in my opinion, context is probably the most important thing. You know, garbage in, you get garbage out, right? Now, a lot of people will say, hey, John, just feed it everything. We have such large context window these days, does it even matter? And in my opinion, even with the large context window, I don't think you should be trying to optimize for using all of it. Because the way these models actually work is that it's basically a statistical output, right? It's a statistical chance that something will happen, some output will be created based on the data that you feed it in. So for context engineering, you really need to think about what is the exact right amount of context that I need to give to the model so that it can do its work better. Nothing more, nothing less. And if you look at Cloud Code and all of the like inner workings of it, you know, the slash commands, the sub agents, the skills, the MCPs, it's honestly just a tool for context engineering that happens to have a really good agentic loop and a model that supports it. Now, once you buy into this concept that context engineering really matters and what you put into the models really matter, the next obvious thing is how do you organize this? How do you organize all of this like domain knowledge and context about your code and about your projects so that the AI can retrieve it efficiently and effectively? This is essentially the second brain concept. The second brain in a nutshell is how do you store context that isn't about the code itself, but about the domain around the code, like product information, product specs, config decisions, domain rules, everything that an engineer actually keeps inside of their head where should that live so that the AI can retrieve it easily? And there's many ways to do this. For Claude Code, for example, you can have a local version of your .claude and you could just put a bunch of things in there. I do this for things that may not belong in the codebase directly. And the other obvious way is committing it directly into the codebase. Recently, OpenAI ran this experiment and wrote about it in this article called Harness Engineering. And here they were saying that they're pushing more and more things into the codebase for the AI to have context. Basically, they're optimizing the codebase for the AI rather than just what we deem normally acceptable for humans. So a really interesting insight and a rule that they discovered through this experiment is that if the domain knowledge doesn't exist in the codebase, then it doesn't exist for the agents at all. So to me, that was really interesting because, like I said, we have so much that's just locked up right here when we work with like just other people outside of the codebase. You know, decisions for meetings, business rules, some new architecture choices that we decided. And when the agent doesn't inherently just know this, we just complain that the agent is not working well. But what if you started compacting all of this domain knowledge into markdown files or documentation, and everything that the agent needs, they can retrieve it using some RAG system. So what I've been doing with my work is really figuring out like what are the key things I need to put into the codebase directly so others can use it, and what are the things that I want in my workflow locally. So these are the things that I'm thinking about. And there's smart ways to do this because over time, if you really go deep on this second brain concept, you'll realize that you'll have a ton of markdown files everywhere. So like indexing things properly that points to other markdown files, like all of these things, the second brain concept, I think is a whole field of engineering that is gonna be a big thing. It already started with like RAG systems, but this is just another layer on top of agentic engineering. Now, pillar number 2 is agentic validation. We just discussed that context is king and context is the most important. But for agentic validation, it's really asking the question, what kind of context is good? And in my opinion, a way to self-validate an agent is gonna be one of the most important things for the agent's output to be dramatically better. Boris Chenry, the creator of Claude Code, talked about this in his workflows when he posted about it sometime in January. So if you give an agent a way to validate its own work, for example, like backend tasks, maybe some integration tests or unit tests. For front end, like client work, it might be the agent actually just navigates the Chrome browser and takes screenshots and validates itself, right? And maybe for mobile, you can actually use the ADB to simulate interactions. Whatever the validation is, in my opinion, this is where a lot of creative engineering will happen. And Boris mentioned that having this validation is a big difference between you're getting crappy output versus something that actually works and is validated. And like I said, this is where a lot of interesting creative engineering is gonna happen, this agentic validation loop, right? For example, validation, in my opinion, is very, very hard, especially for like UI validation. How do you know that this interaction actually works? We don't really have really good video models in the loop yet with agentic coding, but how do you do that without it? Screenshots are okay, but it's not perfect. But you know, you could do things like create maybe a domain-specific language that knows how to navigate your app using like the ADB simulator for mobile, for example. Like there's all these things that you can think about and do. And there's another layer of like logging. What are the observable things that the agent can see right now to help it self-validate? For example, in that article, OpenAI started using logql to be able to log a bunch of files during the validation loop so that the agent can query the logs and validate that, oh, the data is actually correct as well, rather than just relying on tests. And these are the things that you should be asking yourself for your own codebase and your own agentic loops. Does the AI have enough data from its validation loop? Is the visual feedback loop enough? Or is there other mechanisms that you haven't thought of that the agent can use to self-validate? And I think agentic validation, in my opinion, is gonna be a huge part of agentic engineering. Now, pillar number 3 is around agentic tooling. And this ties directly into agentic validation, but I think it's a large enough subject that it should be a thing of its own. In this interview, Peter Steinberger talks about this topic a lot, and he describes it as friction. What are the things that are blocking the agent? What are the friction pieces in the agentic loop that the agent is struggling on? And we've seen this develop through many different like channels already, right? ChatGPT and Gemini, they have like search, agentic search. This is probably a really good example of agentic tooling. Deep research, multimodal, like task systems, all of the things that ChatGPT and Gemini is adding into their chat interface, that's something you could think about as an agentic tool. But you can go a layer deeper. If you look at OpenClaw, which is a really good example of this, a lot of OpenClaw skills, they actually just point to CLI tools. And Peter even mentioned that every time he ran into something where the agent can't do something, he just first reached to build a CLI. And because he had built all these CLI tools to do a bunch of these like agentic orchestrations before, OpenClaw was able to be super successful because it's leveraged all of these things to get work done where previously the agent was not able to do. So in your own workflow, these are the things that you should be actively thinking about and actively building and finding ways for the agent to handle. You essentially need to get to a point where humans are no longer the bottleneck when it comes to the agentic execution. Whatever is slowing down the agents, recognize that is a huge opportunity right now. And should you create a CLI tool, or should you find it or build a specific skill to automate that workflow? Whatever it takes, you really need to think about actively pursuing to remove that friction from the agent. So the next time you run into something when you're coding where you have to manually change something, or there is no endpoint, so you have to go to that website and change something, think about ways so that you can build a system or a tool that the agent can use so you don't have to manually ever do that again. Now, pillar number 4 is about agentic code bases. So the question you should ask yourself right now is your code base optimized for AI agents? I would say most brownfield projects aren't optimized for agents at all. Think about your code base. How much of it is dead code or bad patterns? How much of competing frameworks is in your code base? Maybe you are partway through a migration that never finished, and now your code base have 2 different patterns for doing the same thing. We all know that our code bases that we work at work or wherever has these kind of things, but right now is a moment you should be actively cleaning that up. Cleaning up your code base and doing better engineering has never been more important than right now, because every time bad context goes into your agentic loop, it's basically like the poisoning the agent. And then you might wonder why, hey, why is this agent doing this other thing that I don't want it to do? Like I said, the agents are probabilistic in nature, right? So if your code has weird competing patterns, then you need to get rid of it. You need to actively get rid of it. So dead code and bad patterns is all one thing, but in OpenAI's article, they're even going a step further. They're optimizing their file structure so that it's always consistent, so that the AI can always generate things consistently. They're even adding logging that is agent specific so that the agent can read the logs and things like that. And they're creating documentation not just for humans, but for the agent so that they can keep track of the domain knowledge. Essentially, they encode what they call the golden principles that directly into the repo. They're very opinionated about the rules, and they keep things very consistent for future agents to run, not future humans. And in my opinion, this is an area where we as engineers have to really think about what are good principles. Does dry really matter? Does solid matter? Does not commenting your code in a way that really matter? There's all these things that we have, as engineers have defined as good, but I think a lot of that is going to change, and a lot of this is still being figured out. What does an agentic code base look like in the future? Because you need to remember that you're not just writing code for the next engineer anymore. You're writing code for the next agent to run. Now, pillar number 5 is when all of these things come together, and it's called compound engineering. Dan Schipper, co-founder of Every, talked about this concept. I think he essentially coined the term, and it's a really powerful one if you think about it. Now, all of the things that I've been talking about, context engineering, agentic validation, agentic tooling, agentic code base optimizations, if you do all of these things and if you push everything into the code base so that the agent can see it and share it, and then all engineers working on this are bought into these concepts of agentic engineering, then you have this new behavior where it compounds over time. So the next time you optimize some workflow with a new skill and then you land it, or you've developed a new MCP because there's no good APIs or tools already, every time you add those things and then you add it into the working library, your working code base, then this compounds. And that's exactly compound engineering. And the reason why I mentioned this as like this last point is because all of these things that I just talked about, you really need to like internalize this and then like spread this out. Because one of the most common things that I've seen in my work is that people make workflows, people do things locally, and then everyone kind of works slightly different. Everyone has different workflows. That's actually a huge thing about Claude Code. It's very customizable. But I think in the future, teams will be more like that OpenAI team who's essentially all agreed, all bought into this concept, and they're compounding the work, they're compounding the knowledge, compounding the tools that the agent can use, and over time making those agents be able to just self-validate and keep going and essentially have the code build itself. And in my opinion, like having this mindset, this last final piece of compound engineering, I think it's a piece that you really need to bring back to your teams. So that's it. Those are the 5 pillars of agentic engineering. Now, I don't have everything figured out. I'm still experimenting, still learning by building new things every single day, every single week. You know, some days you'll feel like this where you're building some custom tool for the agent or some custom validation for the agent, and it's just not working. And you might have burned hours and hours going in circles and going back and forth, and might think that, hey, maybe I should have just like written this myself. I think you should really challenge yourself to try to avoid that innate reaction, because you know, I myself love to write code, and I wrote an interesting article about mourning the loss of coding, but this is the future, and I genuinely think that this is where engineering is going to go. And the gap between people who are going to understand this agentic engineering and the people who are just still vibe coding or coding by hand, I think it's going to get wider every single month, month over month. As sad as it is to say, I do truly believe the era of coding by hand is dead. It's sad, but it's true. So let me know in the comments. I would love to hear what your workflow is looking like. If any of this resonates with you. Also sign up for my newsletter, Push to Prod. I write once a week or twice a week, and there's some content that's not here, that is there. And if you're interested in AI coding, I have these videos for you, especially this Claude Code one that's been doing really well. But yeah, I hope you guys enjoy this video, and until I see you on the next one, bye.